Today, electric utilities are embracing new energy technologies and digital grid applications for a net zero energy future. The communication foundation of this new future is a field area network, or FAN. A FAN is a communication network that connects intelligent electronic devices, or IED, such as line switches and SCADA remote terminal units, RTUs, in the field. The Nokia Converged FAN is a service-centric FAN solution supporting multiple applications for grid automation and digitalization. The Nokia Converged FAN comprises the 7705 SAR-HM series LTE router installed on poles or unfibered substations, the Virtualized Service Router, VSR, and the Network Services Platform, NSP. With potentially thousands or more SAR-HM in the FAN, the NSP empowers utilities to manage the FAN with ease. In this video, we will showcase the service fulfillment capabilities of the NSP, including service audit and service modification to connect a new location. We will also look at how you can harness NSP's OEM capability for network supervision with a router LTE uplink. This demo network has a 7705 SAR-HMC mounted on a pole called FR1 pole, a 7705 SAR-HMC called FR2 sub in a substation, and a VSR called CC Headend 1 in the operations center. The FR1 pole connects to a line switch and a SCADA RTU. The FR2 sub connects to an automation controller. The CC Headend 1 connects to a SCADA server. There are already a couple of Goose services set up, connecting line switches on poles with automation controllers in substations. There is also a SCADA VPRN setup, ready to connect the new SCADA RTU on pole to the SCADA server in the operations center. Let's now switch to the NSP and explore how it can manage this demo network. We are now looking at the service fulfillment application of NSP, listing the two Goose services and the SCADA service provisioned in the FAN. The NSP can manage the service lifecycle state. You can have services configured and saved but not deployed. You can have services planned, meaning the configurations are only saved with network resources reserved, but they are not deployed. Or you can have the services actually deployed and ready to carry live traffic, like the three services in this demo network. This lifecycle capability gives you flexibility to provision services ahead of grid application deployment. Let's look at the Goose service called Service 1. You can see the history of the service. Who created this service and when? When was it last modified and saved? By whom? The NSP can also check on the service alignment state to ensure the actual router service configuration is identical to the NSP configuration. By performing an audit, the NSP ensures the router configuration has not been changed. Let's do an audit on the Goose service called Primary Service 345. The audit result shows that two service parameters are misaligned. The first one is the maximum transmission unit, or MTU, size. Someone changed it from 1600 to 1500. This causes the router to stop transmitting long packets. The description field was also changed. This can cause confusion when trying to identify the physical location during troubleshooting. The NSP can easily synchronize the misalignments by pushing down the defined configuration to the routers for the affected service. The misaligned service is now fully synchronized and goes back to aligned state. Service templates can be made in advance to make service provisioning easy. This NSP already has a service template for SCADA with a VPRN, an IP VPN service, a template for teleprotection relay with an ePipe, a point-to-point Ethernet service, and a template for Goose communications with a VPLS, a multi-point Ethernet service. We now receive a request from the SCADA team to connect to a new RTU connected to the field router FR2 pole. To extend the SCADA service to a new endpoint, we will edit the service on the NSP. This SCADA service is already connected to the SCADA server in the operations center. We're going to add a new location for the RTU. This new location is where the router FR1 pole is. The NSP can make a suggestion on the name of the VRF, which stands for Virtual Routing and Forwarding, and then just fill in the rest of the form, including the import-export parameters. Then, we choose the tunnel technology type to connect the new location. The type can be as simple as any for maximum flexibility. The next step is to define the interface on the field router. We continue to fill in the rest of the interface parameters. In this demo, we will fill in the basic ones. On the right, there are optional policy parameters to further customize the service. We will now configure the interface's port ID and VLAN tag values. The RTU site has now been added to the service. Now let's look at the SCADA service again. We see the SCADA service connects two locations, a location on the pole with the RTU, and a location in the operations center hosting the SCADA server. With this service request completed, the SCADA server can start to poll the RTU for electric grid measurement data. Let's switch gears to look at NSP's network supervision and other OEM capabilities on the router's LTE uplink. To do that, we have created key performance indicators, or KPIs, and threshold crossing alerts for resources on the FR1 pole SAR-HMC. Let's explore what the NSP can do. NSP's Insight Administrator application is used for the lifecycle management of network KPIs. Since a high-performance FAN requires consistent LTE signal level, let's look at the first indicator in the list, the Reference Signal Received Power Level, or RSRP level, for LTE port 111. The indicator is enabled with a collection interval and window duration of 1 minute each. To preserve compute and storage resources, both parameters can independently be increased to 5 minutes as an example. In that case, the indicator threshold and value would only be evaluated and stored every 5 minutes. The indicator RSRP is measured in decibel milliwatts, or dBm, since this is an LTE signal level. We now look at telemetry type and counter, and the formula applied to the counter to determine its value. We select the maximum signal level measured in the 1 minute window and convert it to a positive value by multiplying by -1. The formula can make use of other attributes, mathematical and aggregate functions if needed. The object filter specifies port 111 of the FR1 pole router. Two thresholds have been defined, one for increasing level and another for decreasing level. Both trigger the alarm action. Other possible actions include Kafka event generation and email notification. NSP's fault management application tracks threshold crossing alerts, TCAs, and all other alarms in the network. It has detected that a TCA alarm has been raised for the RSRP indicator. The information panel can provide the date and time of its occurrence, the indicator name in the alarmed object name field, and the router and port details in the object full name field. You can learn the threshold crossing details by scrolling down. Monitoring LTE signal level is not a one-time effort. It requires monitoring the trend continually. The NSP Insights Viewer application provides insight in the long-term RSRP level trend and more. It can combine the RSRP indicator with the Received Signal Strength Indicator, RSSI, and Received Traffic Indicator to display them at the same time. To investigate the RSRP threshold violation, we can zoom into the period immediately surrounding the violation. We can observe the correlation between the RSRP and RSSI, and also know that traffic received is, fortunately, still within both of its thresholds. Therefore, we can conclude that there is no impact to the SCADA service, and acknowledge the RSRP TCA and move on to other tasks. NSP is at the leading edge in communications network management, optimization, and automation. It is simple and intuitive to use for efficient and reliable operations. It empowers utilities to manage the FAN to connect IEDs at speed and at scale, today and tomorrow.